This video explores the statistical technique of running a regression. We'll talk both about a bivariate regression and a multivariate regression. So let's start out with the technique of how we run a simple bivariate regression. In SPSS, we select the tab for Analyze, Regression, and then we are going to use linear regression. So that's Analyze, Regression, Linear. And once we select that, SPSS asks us which variables we'd like to explore in our regression, and let me clear those out first. So what we do as normal is we select the variables that we'd like to include. Notice with SPSS we have to identify a dependent variable and an independent variable, and as you remember from our class discussion, the dependent variable is the one that is predicted by the independent variable. So let's use an example from our movie theater data. Let's use the dependent variable of question 8A from our survey, which was the issue of how you purchase your movie tickets, and this is the one that relates to purchasing tickets over the internet. And we'll use an independent variable as one of the sources of information. I'm going to select the internet information source as the independent variable. So what I'm saying here is that I'm predicting that the independent variable of the importance of an information source of the internet is going to influence whether or not I purchase my tickets over the internet. As you remember from our discussions, correlations and regressions are different, because with regressions we're saying this variable causes that variable. The independent variable causes the dependent variable. When we run regressions within SPSS, we leave all the default options alone and just say OK, and this is what our output will look like. We see a model summary table, an ANOVA table, and a coefficients table. So let me walk through each of those and focus on some of the things that are important. As we talked about in class, R squared is the summary of the percent of the variation in the dependent variable that is due to the independent variable, and you can state this as a percentage. So 0.006 is actually a percentage. It's 0.6%. So you move the decimal placement over 2 spaces to the right. So this would be a very, very small adjusted R squared, and this adjusted R squared is the place that we look for the percentage of the dependent variable that is explained by the independent variable. So the adjusted R squared is the first place we look. In addition, we like to look at the p-value, or the significance of this regression that we've run. There's 2 different places it's shown in a bivariate regression. Let's jump down here to the coefficient table, and you see the independent variable listed here, the information source of the internet. On this row is where the important information is shown. If you scroll all the way over to the significance level, the significance is the p-value. And in the row for the information source, you see that the p-value is 0.064, and as we know, that's less than 0.10, so that's a significant relationship. And in addition, in regressions, we look at this t-value. That's a statistic that shows the strength of the relationship. What's important about the t-value here in our regression analysis is we look at whether or not that statistic is positive or negative. If there's no sign in front, it indicates that it's a positive value, and that means that the independent variable influences the dependent variable in a positive relationship, meaning as the information source of the internet becomes more important to me, it's more likely that I'm going to purchase the tickets over the internet. If that was a negative number, it would be a negative relationship. As the independent variable goes up, the dependent variable would go down. So that's what we look for in a regression. This is a univariate regression. The interesting thing with a univariate regression, the significance level up here on the ANOVA table, this is the significance level of what's called the overall model, all the variables in the model. Notice the p-value is exactly the same. With a univariate regression, you'll have the p-values be the same between those 2 tables. Let me show you what it looks like when we do a multivariate regression. And as we talked about in the lab, you'll see the multivariate regression is very similar, but one important shift. We still do analyze, regression, and linear. The only difference is I'm going to use the same dependent variable I used before, but this time, since it's a multivariate regression, I can have a long list of independent variables. So I'm going to select all of the information sources in our movie theater data set. So I'll use all of these information sources as independent variables. So I'm exploring how all of them together predict the likelihood of me purchasing my tickets over the internet. So when I say OK, You see a similar looking set of output. We still have the adjusted R squared. In this case, the 0.046. Remember, we can move that decimal place over 2 places to the right. So this is actually 4.6%. So the way you state this is that 4.6% of the variation in the dependent variable is explained by this set of independent variables that I've included here. I also look at, in the ANOVA table, this significance level tells me the significance of the overall model, meaning of all of these independent variables predicting this one dependent variable. It's highly significant. A p-value of 0.000 means that there's strong statistical significance in this regression model that I've just created. We look down at the coefficients table for all of the details of, first of all, whether or not each individual variable is significant. Remember, we use 0.01 for the p-value cutoff level. So everything in the significance column that is less than 0.10 indicates that it's a significant relationship. In addition, we look at the t-value, the statistic, and we mainly look at the sign. The negative signs in front mean that the information, the importance of the information source of the newspaper, as that goes up, it's less likely that I'm going to use the internet to purchase my ticket. So that negative means a negative relationship between the variables. This one above it is a positive relationship because there's no sign that indicates that's a positive t-value. So we can look at the p-values, the sign of the t-value, and in a situation with a set of independent variables, you'll notice that some of them are significant, such as the internet and the phone and family and friends, and several are not significant. This 0.99, 0.196, 0.14, all three of those are higher than our 0.10 cutoff level. One of the nice things that we can do in this set of independent variables is also look to see which one appears to be the strongest predictor, and we look for the lowest p-value in that situation. And you see here it appears that the phone, of 0.008, is the strongest predictor, and it's a negative relationship. So as this one goes up, the likelihood of purchasing the tickets over the internet goes down, and we can indicate that this variable is the strongest of the predictors that ended up being significant. So that's how we do a multivariate regression and what we look for.